A few days ago, we were present in the Niasar area of Kashan for engineering geophysics studies around the famous Niasar Waterfall. This area you are seeing, the green part is the same Niasar Waterfall, which is actually a spring that comes from here and reaches this higher area and empties itself as a waterfall. Here two topics were interesting to me, which were important for interpreting our geophysical data, for me to gain a strong geological perspective. That's why I worked on this method with my brother and obtained interesting results that I wanted to share with you all. Look, this waterfall here was formed by this spring and created the elevation difference of the waterfall. But the point here in this area that I will show you approximately in a circular way. And in this area, we have Travertine. Now I want to talk about how this spring formed, which consequently shaped the waterfall and this Travertine and the connection between them. But before that, I want to let me show you a picture of this area. See, this is volcanic. This area I'm showing is dark colored, belonging to volcanics. This part too, both of these are volcanic, and this is a limestone, the red colored formation. I will overlay this to show you the geological map. This volcanics, they are impermeable, on both sides of us. Here is volcanic, and they are impermeable. This is also volcanic, two types of volcanic. But this is limestone, which is permeable and has become karstic. This limestone that is beautifully positioned here has extended exactly to the point where, let's assume it was not present before, at the contact between these ocean volcanics and this limestone, forming our main spring. This spring has caused that, and this contact has caused the spring, the karst water that was in the limestone and was moving through this area, to reach a dam at this contact point and form a very interesting spring. But here we also have Travertine. Now, what does the story of this Travertine trace back to? I want to talk about both the formation of the spring and this Travertine. Look here, we have Travertine here because, well, we know there was a subduction in the past and there were geothermal gradients within the earth. This geothermal gradient caused the calcium carbonate that was in, there has been depth, dissolving more intensely, and when it presents itself with mechanisms in this way, like we would see here in the spring, this water rich in calcium carbonate reaches the surface and is deposited as Travertine. This spring is formed through a mechanism of interaction between volcanics and limestones. Furthermore, as it was rich in calcium carbonate, this water, here in a circular form, we have a Travertine spring, a Travertine area. Then this spring, because it wanted to pave a way for itself, and from the other side, its calcium carbonate would be deposited layer by layer and rise layer by layer. This rising layer by layer caused a height difference between this point and that point, and consequently, a waterfall-like structure would form here due to this height difference, meaning the water that came from the spring to this difference. It happened to discharge itself and this waterfall would form. Now, in addition to this, we clearly see an uplift, a calf here, and this calf is very clearly visible here. But now, this spring is not necessarily, this waterfall is not solely because of this uplift that we have here, and it has now manifested itself as a waterfall. In fact, this stratification and layering of this Travertine area has been the main factor in creating this waterfall. And